All right, you guys ready for notes? I hopefully have my writing thing, the challenge with writing thing. All right, so we're looking at concentration changes over time. We've already kind of alluded to these a little bit, okay? But you can look at these concentration changes over time, and you can determine from that data what order reaction you have. And this is where your calculator, being able to put that data into your calculator during the exam, is going to be helpful, because you can hand crank all of this stuff, or you can put it into your lovely graphing calculator and have it do the work for you. So that is what that intro video is. And it is by a lady who used to teach AP Chem, and she has a deeper, more pronounced accent than I do. So yes, it is from Texas, and she says y'all a lot. Okay, so when we are looking at graphing the reaction versus time, so we've got our concentration over here. I'm going to move this. It's going to pop me out. I'm going to have to come back in every time. That way you can see. There we go. Now I got it out of the way. So we've got concentration here versus time. One of these has a straight line. You see that? If it forms a straight line, negative slope, if I'm using my terms right. Yes? Okay. If it has a negative slope and that is a straight line with a concentration versus time, then that is a zero order reactant. Okay, so you can look at a graph. If this line is straight for whatever this concentration of X, they're just calling it X here, that means that it's zero order. Okay, now the red line is given here with the concentration versus time. Okay, now I can look at this red line and I can figure out that that's actually first order from this information. Now the yellow one, I can't. I'm going to show you how to do yellow in a second, okay? But the way with concentration versus time that I can figure this out is this has a defined half-life, okay? So when we look at this, if time is 0 here, we have 5. If I find where that has gone down by exactly half, that's right here. Okay, that's right here. I think I can draw in here now. Okay, so I can figure out what that value is. So what do you think that is? Like 3,500 maybe? I don't know exactly. If I go another 3,500 for a total of 7,000, okay, which would be right about here, okay, this should have gone down by half again. So here I was at 2.5. Here I'm at 1. So I'm a little off here. But if you have like actual data that you can figure out, it's going to go down by half in the same amount of time every time. Okay? And we'll see that as we're moving along here. So, like I said, if we have this reaction and concentration versus time gives us a straight line, that's a zero order reaction. If that is the case, then you will have your rate is going to equal K, which we learned yesterday. We can also take this example here and we can rearrange it. Okay? This equation is on your equation sheet. So if you know the concentration of K at a given point in time, Okay, so let's say that right here we're given 1,000 for seconds, and the concentration is 2.5. Okay, and you knew the concentration in the beginning, and you know the time. You can solve for K here. This equation's on your equation sheet. You need to be able to know which equation to use based on what order reaction it is. So let me see if I can find a copy of that equation sheet. I have a better... Yeah, this is the stuff that's on the rate law on the sheet, okay? So if it's zero order, you're going to use this one. If it's first order, you're going to use this one or this one. And if it's second order, you use that one. And these are on your equation sheet. So if you flip your periodic table over, they're in this, and they're in order 0, 1, 2 on your sheet, going down. Okay. This is not a 1, though. This is natural log right here. That's ln. That's natural log. You know natural log? You're going to learn. Okay, we went through this slide. We went through this slide. Okay. So first order reaction, we can rearrange our slope here. Okay. So we can look at the different factors of this. We know our y, we know our x, because we can get that off of, God, I hate this thing. Why does it have to be such a brat? Okay. So if we can use this on our equation sheet because the slope of the line gives us this information, right? Okay. So if we graph this and we graph the natural log of the concentration of the reactant versus time, that will give us a straight line. Okay, with a negative slope. Negative slope? Yep. It's been a while. All right. Now, if we rearrange this slope equation again, a third time, and we graph 1 over concentration. So this guy over here, he says 1 over the concentration. And this is Z. So that's what that says off to the side there. It's just going to kind of cut off. If we do 1 over concentration versus time, and it's a second order reaction, it's going to give us a straight line. This is where your calculator comes in handy because it can graph these 3 different things very quickly for you. And you just look for the one that gives you the straight line that tells you what order it is. So once you get that data set in, you run a graph that has this as your x. You run a graph that has natural log of x, and then you run one that's just x, concentration versus. She takes you through it on the calculator video, if you watch the calculator video.
So like when you plot this, is like it's like 1 over like a value on the graph, and then minus.
Yeah, so you're going to take whatever item you're looking at here. So we're looking at item A. Yeah. So reactant A. Okay. You're going to do one graph. The first graph you're going to do is going to be time on the x-axis. And on the y-axis, it's going to be your concentration.
I get that.
And then you're going to run another graph. Well, if this is a straight line, you just stop because it's 0 order. Okay? Then you're going to run another graph that's time on the y and the natural log of that concentration. If that's a straight line, it's first order, you stop. If it's not, you keep going, and this time you're going to do 1 over concentration, and that better be a straight line, because if it's not, something's wrong. Because it needs to be one of these 3 scenarios. Yep.
Do you have to graph every single one, or for like if you know it's first order, can you just skip to the like second one?
If it's first order, don't bother to do this.
Oh, I thought first order was the second one.
First order. This is 0 order. This is first order, and this is second order.
Okay.
Did that answer?
Yeah.
Okay.
Then it's first order. Don't we do the second one?
You don't need to. You don't. Yeah. Yeah. You just don't need to do this one.
So do we do the one before it?
Yeah, because you start with 0 order, because you got to type that concentration in anyway into your calculator, and then all you're going to do, if you watch her video, all you're going to do is set up another column. You're just going to change the column heading to natural log of that concentration. Once you have that concentration in, and you watch that video, all you're doing is manipulating essentially the title of that column.
Can I ask what natural log is?
No.
No. Okay.
No one knows.
Is it like log, or is it just way different?
Is it like log, or is it just way different?
It's log based.
Yeah, log base E, but I have no idea what E is, and yeah,
It's like 2
We're
point
messed
something.
up.
it's go talk to a math teacher, because it's been. Do you know what a log is?
Not entirely. That's our last
Okay.
unit of the
Oh,
class of the year. You know.
No, God.
No,
He can stay out.
no. I need to get through this. If we have time at the end, we can go get Budro, but I want to get through my stuff. For you, natural log is a key on your calculator that looks like this, and you press it. Okay? And if you want to get out of it, you do
The back.
E to the X, I believe. Is that what's on top of that little key on your calculator? Yeah.
So is
So
AFT and
this gets you in, this gets you out.
is AFT and A0 just like a different point on the graph, like just 2 different points basically?
Is what?
Like in the
Here. So this right here, this is at 0. This is your initial concentration. This is at a specific time, which is represented with that T.
That was my question.
Okay? So you pick a time on here. It doesn't matter
Yeah, I get it.
which time it is. Just make sure that whatever time you pick, that you get that concentration off of, that is the time that you enter right here.
All right.
That make sense?
Yeah.
Good? Okay. This is where the power of that fancy graphing calculator that is going to come in handy for you. And you're going to want to own that thing and love it, because it is going to be a treasure for you. And if you don't have one yet, talk to Santa, because this is something you're going to want to request. I'm telling you guys, the higher you get up into math, the higher you get up into science, you're going to appreciate that calculator more and more. We used to have to look up like cosine, tan, all of that stuff. We had to look it up in the back of our math books. We didn't have calculators that could do that for us. So, love your calculator. Appreciate it. All right. This is what I was trying to explain in terms of half-life. It is pretty common. It is pretty common for you to end up with a problem that will involve a first order reaction where they're getting you to use half-life to solve. Okay? So you can only use the equation on your equation sheet for half-life for a first order reaction. There are other equations for other orders out there, but they don't apply to AP Chem. So you're not going to worry about muddling your brain with that extra stuff right now. I'm just putting it out there that it exists so that when you get to college, you're like, Lippy never I'm like, yes, I did. We'll go back and watch the video. Okay. So when you're looking at a first order reaction, you can get information off of here to be able to figure out your K value. All right. There is a formula on your equation sheet that looks like this. T1/2 equals 0.693 over K. Again, this 0.693 only works when you're using a first order reaction. Okay, this will not apply if you have anything else. So if you know your half-life, so when did this material go down by half? So here we're looking at the first order reaction. We know that this is a first order reaction. Okay, we established that with a straight line a couple slides ago. Yes? Okay. So I can see here that at 2.5, I've gone down. Here's my 2.5. I find that time right here. Okay. I can see that when I go down to 1.25, that time is the same amount. So if I know how much time it took to go from here to here, I can plug that in to my equation and solve for K. So the amount of time that it took for this to go down by half, what do you think that is? This is 0, this is 5,000. 1, 2, 3, 2,800. Does that sound valid? So I could fill in that 2,800 here equals 0.693 over K, and I can solve for K. That's going to give me my K. That gives me my rate constant that we talked about yesterday. Remember K? Okay. Okay. This is a very common equation, usually every year. One problem, either FRQ or multiple choice, will have you use that equation.
Is it always in seconds?
No.
Okay. So wait, if it's not always, you just use whatever time value it gives you?
Yep, and then your K, your rate
Oh,
constant, will be reflected. Yep, it will be reflected in your rate constant. So if you look over here for your units, right? Meters per second, it could be meters per hour or molarity per hour. It could be molarity per minute. This is where that rate for your rate constant, that's where the time will be reported. Okay?
What about the 1/2?
This right here, that's just saying half the time it takes for half of it to go away. It's called a half-life. So here's another better kind of example of that. If we started here, it takes, to go down by half, it took 5.27 years. Okay. So they're saying that it took this amount. This is a half-life. So this is how long it took to go. And they're saying that that took 5.27 years. So you could do your 5.27 equals 0.693. Did I write that down right? Is that the right number? Okay. Divided by K, and you can get your K value. K is your rate constant. Hey there, hon.
Hey, I was just dropping something off for you.
Thank
I'm
you.
try and slide it to the door.
Oh, that's fine. Thank you. Oops. Okay.
You do?
Um.
Is this why this was in there?
Miss Congo said you have coasters.
Yep. They are glass, so be careful carrying them, okay?
Glass coasters.
Yeah, I do glass etching for gifts and stuff.
Okay.
That's sweet.
You have many hobbies. Are there any other hobbies you're keeping from us you haven't told us about? Glass etching, caramel making,
Don't you?
crochet
I've
book
got this
club.
stuff to do, but I haven't tried. I got rid of all my crochet stuff. I got tired of that. Yeah.
Quilting.
is fun.
Did you knit?
No, I got rid of all that.
She quilts.
We're gonna find out she restores
Oh,
lots of colors.
cross stitch. I do
Cross stitch.
You should try doing your wood.
The glass etching is part of the Cricut stuff. So you know how I use the Cricut stuff to cut.
Yeah.
So you do the stencil on the Cricut, and then you just put the glass etching cream on the glass, and it etches it. It's pretty easy to do. Yeah. I could.
You used for a Cricut on one.
We could probably do some stuff in here as kind of a fun thing with it. Yeah, I could bring stuff in. Yeah.
You should do that on like.
Just
Yeah.
Add a few more things to your plate, Libby.
Do it when you're
I'll
less.
make a whole lesson plan.
It's a hobby. It's a hobby.
Okay, so
Fun.
So yeah, you can use the K value, you know, so this is very handy, okay? So your K, what is M? Is that your slope of your line? Is that right? Okay, so your K is your slope of your line. Okay, so if you are given a graph and you can figure out what the slope is, so this is what you're going to do with your Crystal Violet Lab tomorrow, okay? You're going to calculate the slope. That slope then ends up being your K value. And then you can figure out, you know your known concentration, you can figure out your other concentration and go from there. So it's kind of cool. You figure out the slope of line.
So if you know your slope, then you can just figure out.
That's your K. Slope is K.
Is slope K on everything?
If you have
All
them
the equations?
If you have them graphed correctly, yeah. So this table here I've got in your notes, right? And again, we've given you these equations here for half-life of a zero order and a second order, but you're never going to have to use those in AP.
Yes.
Okay. I want you to know that they exist, and I want them to have it in your arsenal when you go off to college. Okay. Because it might come in handy there, but we're never going to use them in here. Okay. But they can be helpful in college, you know, if you need them there. So know that they're out there because you may need them someday. Okay.
I've never done. I love saying matrices. It's such a good word.
Okay. So this graph, I saw a squirrel there. Sorry, you guys. This shows you what K equals. Okay. So if you have a zero order reaction, okay, and you graph concentration versus time, that K value, your slope is going to be negative K. If you have a first order reaction and you have a straight line, natural log versus time, your slope is negative K. That is what the slope of the line is. If you have a second order reaction, you have 1 over concentration versus time, the slope of that is going to be K, not negative K, K. Okay?
Wrong word.
This chart pretty much summarizes everything that we've talked about today. So that's why I like going to this chart. I think it's very handy. It kind of puts everything kind of concisely together for you. Okay? You can also look at data. Sometimes you can just look at the data and see from the data, okay, the rate here is unchanged. No matter what the concentration is, that's zero order. Here, if I look at my concentration, This is going up. The rate is going at the same change as the concentration. That's first order. And then here, if my concentration has, gone from 1 to 2, this is the square. Okay, good. So you can look at data, or you can look at slope. You can look at, there's lots of different ways to try to tell out what order reaction you're dealing with. And then please know how these things work for your units. Because if you solve this with the right number, but your units are wrong, they're going to mark it wrong and you're going to lose the points. And that really sucks. Okay.
I couldn't even research.
So how many people have looked at and watched the calculator video? Has anybody watched the calculator video? Okay. You're going to watch the calculator video this weekend, and by Monday, you will know how to use those graphing calculators. I will come back to this equation with you on Monday, and we will check to see if you know how to use your calculator or not. Okay? And you will pinky swear with me that you will do this assignment this weekend, yes? Okay. All right. There's still hot chocolate back there, and we have about 8 minutes. So if you are interested.
You
Huh?
Do you have a charger for your graphing